Okay, so the question is what numbers to put here so that whatever numbers we put here, we get the population of the first tree after transition, right? Okay, well, what contribution to the total population would we have from the first tree here? Like how many of these 10 bugs are still on the tree?
85%.
You say 85?
Yes.
Sounded like 35, but I just realized I don't have my hearing aid. Okay? So I knew, anyhow, that I might not have heard that correctly. Okay? Well, yeah, I mean, what's happening to this tree? You're losing 5% here, right? And you're losing 10% here, right? So the number you'd multiply by this 10 here is 0.85. It's the 85% of the bugs on that tree that stay on the tree, right? Now when I write out the entire solution, I better clear this so that we can see it. I'll not be able to write as big as I'd like to. So we're going to multiply this by 0.85 because what we want to get is the number of bugs on the first tree. And of course, I can't even read the word tree there, it's chalked a little wide. 85% of these 10 bugs will still be on the tree, right? Okay, so kind of keep that idea in mind. Now, what would we multiply by the population of the second tree to get its contribution to the first tree? 0.1, 10% of them, right? Because 10% of these bugs will be on the first tree. So we'd better multiply this 10 by 0.1. How many of these bugs are going to be in the first tree? Yeah, bugs don't jump trees. The bugs got to go from this tree to this tree before they get to this tree, and that's not going to happen on the very first transition, is it? Okay? So none of those are going to be on the tree, and none of the 100 are going to be on the first tree, right? So what we have is 0.85 times 10 plus 0.1 times 10 plus 0 times 10 plus 0 times 100. Okay? Equals this. I'm going to write that down here so I can okay. This is the 8.5 bugs that were originally on the tree that still are, right? I'll use a circled 1 to indicate tree 1. Is that okay? And those bugs are still there. Okay? Now this 1 was originally on the second tree. And it's not still there, now on the first. Okay? And then the zeros, you know what those mean. No bugs on the third tree, because that's what we get if we do the 0 times 10, right? None of these bugs go to the first tree, none of these bugs go to the first tree. Okay? Make sense? Okay, now let's do the row that you would multiply by the population vector to get the bugs in the second tree.
How much is remaining?
And actually, let's skip that. Let's go to the third tree. Because the second tree is a little less informative than the third, okay? So we're going to have a matrix, or a row, again multiplied by 10, 10, 10, 100. To get the number in the third tree, and implicitly this is the number of the third tree after the transition. So what would the matrix be? We want to ask ourselves, how many of these bugs end up in the third tree? How many of these end up in the third tree? How many of these end up in the third tree? And how many of these, right?
Yeah.
That's the question we have to ask to figure out what numbers to put in here.
All right.